Good. Okay. Yeah, so I guess you guys asked me to come here today and talk about S7. So I'll take you through the sort of overall philosophy, what we are thinking, and then some practical implications at the end, for porting over bioconductor, in particular, that the issue that was brought up around the multiple versus single inheritance. So I've added a couple of slides on that. And then we can I'll probably try to move through fairly quickly and may not touch upon all things because we think we probably want to have a discussion here. And I think a lot of people here are already familiar with a lot of these concepts. So, all right. So just to remind everybody that S7 is a collaboration between our core, Posit, and others, R OpenSci. It was really facilitated by the R Consortium. And Posit, in particular, Hadley and Tomasz and Jim really contributed like the vast majority of the code, whereas I was more leading the working group and bringing in people from our core like Martin and Luke, who really contributed in some valuable ways. So it was pretty good collaboration. And yeah, so today I'm going to talk about why we're doing this, and how S7 solves some of the issues that were bugging us about S4 and S3, that whole dichotomy, and then maybe go into an application to this LLM interface, but that's probably not really core to this discussion. Um, so I think everyone's familiar, with this book, this model for how R enables data science. And you can kind of see how the object orientation of R really maps into that. So in this diagram, your edges are your objects, the things you're pushing around, and the nodes represent the operations you're performing. And so everything in R is an object. That's how we store data. That's also how we store code. Everything in R is an object. And then everything that happens is a function call. So the operations are implemented in functions. And this thing also laid out that this book by John Chambers, Extending R, also laid out these are the four principles that he laid out. But he also said that R is an interface, interface, a glue between different languages, and I would even say that it's a very important user interface, a tool for people to use to analyze data, and so that's really important to keep in mind as we think about how the user wants to work with data and work with objects. And R is also, I guess, in the title of this book, R is very extensible, and the object orientation is key to enabling that extensibility. Okay, so you could say that R is an extensible, functional, object-oriented user interface. And I'll try to kind of refer back to these concepts. But the overall idea is that the user is able to take these objects, call functions on them, and ideally be able to call intuitively named functions that have like a purpose, a common, a similar purpose, but they behave differently based on the type of object. So you might have a data frame, you might have a date time object, but calling print on either one of those, does the analogous thing. And the way that R is able to specialize its implementation of different types of objects uh, is at the base of it, this S3 dispatch to these underlying functions. But in general, in computer science, we call this polymorphism. We can write the same code that does something different based on the type of object. And it's really important for providing a nice abstract user interface. And this this branching, the actual branching and how you do that dynamically at runtime based on the data type is called dynamic dispatch. And I would say that, as I kind of thought about all the different approaches to object orientation from, languages like Rust or Java or C++ or I don't know, Haskell, you can the commonalities are really this polymorphism and dynamic dispatch. And that's kind of core to not every object-oriented language has classes. Not everyone has inheritance, but they all have some form of dynamic dispatch based on the data type. Um, I'll go through a little bit of history here. Maybe it's not so important for this talk, but we this whole idea of functional OOP was inspired by what we'd call message passing object-oriented programming. And so the kind of classic uh, use case and really the motivating use case for message passing OOP was the model view controller paradigm, right? Where you have the user interface, where you have an underlying data model, the user interacts through some kind of controller or a user interface, like a mouse, pointer, and so modifying or changing the underlying data model, and then those changes then propagate to the different views. Um, and this was all developed around 1980 at Xerox PARC as part of the work on Smalltalk, where they invented the modern user interface, the window menu icon pointer interface, the WIMP interface, and this idea of mapping objects to the user interface, and so this MVC paradigm was key to that, and they were the ones that really kind of set the course for object-oriented programming as part of the Smalltalk language. Um, and so in this paradigm, you have objects that act like stateful agents. They have they need to encapsulate their state because changes to the state need to be propagated appropriately. And so they have a fairly different approach from our what we call our functional paradigm, which was introduced by CLOS, or the Common Lisp Object System. And the interesting thing about class and the functional approach they took is they separated out because they were function first. They wanted the functions to implement the behavior. They didn't want the behavior to be embedded within this agent. But then of course you need the objects then represent the state, and you sort of decouple this idea of behavior and state. And then at that point you can now start saying, well, now I want my functions to dispatch, based on their inputs. And those inputs could be multiple. You're no longer sending a message from one object to another, which would kind of necessitate single dispatch because you're really just dispatching to one object. You can now have these functions that can take any number of arguments and dispatch in any number of them. So it gets you a lot more flexibility. So we definitely wanted to stay with the functional paradigm when approaching S7. And I'm kind of skip through some of this stuff because I think you guys are kind of like preaching to the choir on some of this stuff. But well, why it's so much easier to extend and so much more flexible, especially when you're thinking about data transformations. I want to map this object to this object. Having double dispatch for that is really convenient, and just in general having packages that can add additional methods, register additional methods, either for a data type they define or data type somebody else defines, or there's just that extensibility is something that is not found in these other message passing approaches. Um, yep. So here's another this slide's. I mean, it's just kind of comparing. In case somebody was thinking about Julia, and we oftentimes get people coming to us and saying, why can't I define I have a generic like Julia where it could take any number of formal arguments. It's just kind of like avoiding name collisions, right? You have we always kind of push back and say, no, we still want these formal generics that exist and are documented and have a singular purpose. In other words, like, you're not going to call print and then have it print something to a printer. It's always going to print something to the console, right? Generic has a defined purpose that you're going to pursue. Um, and yeah, so we really wanted to hold true to the S3 and S4 approach, the CLOS approach of having these we call like reified or real generics. Um, and yeah, so
Hey, Mike,
the
maybe
S3,
we could
yeah,
just
please,
jump in for a minute.
yeah.
Um, One of the things that comes to mind in terms of this generic concept is, I don't know how to put it, regulation or governance.
Hmm.
Like, I can define a function to do something that is interesting to me, but making it a generic because I think there may be other deployments of this concept. It sounds like it's something that people should make a decision about. We have BioC generics. We've had it for a really long time. I don't think I've ever really gotten involved with it. But deciding on when something should be regarded as a generic and get that status, is that something you have any thoughts about? guidance?
It's very common. Yeah, I mean, it's a great thing to bring up. I mean, it's a common sticking point, when it comes to collisions across different frameworks. I mean, you have the kind of classic tidyverse versus bioconductor, and having a few generics there that are in conflict. And it's a thing where it kind of allows for um, very organic alignment around different verbs, and function naming and signatures and all, like a common interface, right? And that's something that is kind of unique. I think it's unique to R in that sense. I don't yeah, I mean, I think that idea of having a community of people develop, contributing code into this collective, and then having them sort of organically align on things is pretty interesting, but it definitely breaks down in some instances, right? Like you have these places where you need like adjudication of one generic versus another. And I think that's just where we're going to have to be, um, everybody in the art community is going to be good at, sort of negotiating that or aligning on that if possible. But I mean, there's always going to be, um, a downside to that where you're sort of you're blocked, or there's some inconvenient name clash that is not resolvable. And so yeah, we always kind of, of course you can always fall back on the package namespacing for that, but that's not super convenient given we want people sort of naturally working in the console, right? So ultimately you kind of want this everything to kind of be merged into a workspace that everyone can use. But yeah, anyway, yeah, great point. I don't really have a great answer to it.
So with S7 though, it'll be the same situation. You
That's
can
right.
create
Yeah, like
generics ad libitum.
yeah,
Yeah.
that's right. Yeah. Yeah, the only way I guess you can, I mean, I guess the Julia approach would be one way to get away from that, but it's just fundamentally, if you're trying to provide an environment where, you type a word and it does the thing you expect, you just need to agree on common semantics. And so that, yeah, that's just I guess just a core tension to all of this. Um, okay. Yeah. So just I guess it's probably reminding people here, right? I mean, this is the S3. Everyone's familiar with this, but they really are, looking to mirror, the generics and methods of class, and they did so actually using a fairly, well, I might say, natural or idiomatic syntax. Although they have this sort of strange convention of this whole period, uh, class, mechanism for registering a method. The other weird thing about it is that there are no separate self-standing or reified class definitions, right? So you don't have this idea of a common class. You now have everything, just instances are just labeled, and that labeling is what controls how dispatch occurs. Um, but again, dynamic dispatch, so therefore an object-oriented system. Um, and S4, I think in some ways, I'm guessing, yeah, I think it's safe to presume that John kind of went back to Claus and said, how could we do this right? Like, how can we be truer to how Claus was doing things? And then you could see how the syntax even was much closer, but also it supports the class definitions of Claus. But you can see how I don't know if you guys know, but like Class, and this basically, eLisp, to those who still use Emacs, eLisp is derived from Class. And it's really natural actually in Emacs to be able to, redefine and kind of inject, code, as the editor is running, in order to make certain things happen. You can rebind things, you can add, advice to functions, like things that run before or after another function is run. You have this very dynamic environment, that allows people to get their work done in the editor. But I think R is a little bit of a different use case where you don't actually need to have this level of mutability of the environment, like at runtime, where like users are trying to like, define their own classes and methods and inject them to make certain things happen as they sort of customize their environment. That's not really how most R users are working. And so it's not a perfect match to what we're trying to do. But anyway, we ended up with a very similar syntax where these side effects, right? There are these side effects where you set class ranges, just like def class ranges, and something gets assigned into a table somewhere. And then you start referring to classes by their names because those classes are again registered by their name in these tables. Um, anyway, I'm getting ahead of myself, I think, because I'm talking about the downsides rather than just talking about how, it added classes. Anyway, so the problems, I think everyone's aware of these things. S4 objects are not S3 objects. So this is kind of a somewhat convoluted example, but if you define an S4 derivative of a POSIX CT, and then you instantiate that and look at its class, it just has this S4, the class vector of S4 objects is a scalar, it's a single name of the class. And that, again, that gets looked up into a table, but you don't have the linearized class hierarchy in the class attribute. And so what that ends up doing is, well, I mean, and like you would with S3, right? Um, and so that is actually, well, very subtle. It makes it so these objects aren't the same, right? Their behavior is kind of fundamentally different just in terms of how they express their class. So we want to get back to how the S3 define to be compatible with S3 objects. So we went that route of having a class attribute that that represented the hierarchy or the linearized hierarchy. Um, so uh, yeah, I said it before. I already kind of went through this that S4 really maybe was a little bit too faithful to class, so that was one issue. Um, Probably just kind of skip through some of this stuff, but one of the interesting things um, is that uh, when you think about the whole slot issue, this has been a kind of a thing that's kind of been a thorn in our side for a while because users would want to look at the structure of an object and would oftentimes be getting into the slots of the object rather than going through an abstraction layer. And that ended up, uh, you know, often we would because we would want that we wouldn't want that abstraction to be violated. We would oftentimes have to chastise them, saying, you need to call these functions instead. Um, but um, but in some ways, though, if we kind of think about the reasons why we didn't want to expose an implementation, one is that it really was, that was the lowest level of abstraction. There was no way for us to control, like, once somebody gets the start attribute of an iRanges object, they've got the underlying implementation of the object. There was no way to interject any logic to protect against, to abstract that in any way, to protect against changes, right? Um, the other thing was that because we want our implementation to be minimal in the sense that like an iRanges object will just have a start and a width, but not an end also because end would be redundant. Um, that that though, if you think about it from sort of the user interface perspective and somebody wanting to think of this thing as a natural object, they might want to get the ends. And we had no way, to define to elegantly define an end slot because it would just make the implementation redundant with itself, which is not, definitely adding complexity and not something you want to do when designing data structures. Um, so there was really no way, um, really no protection besides telling everybody to call functions. And functions actually are a lot less discoverable, for example, than taking an object and saying, what can I do with this object? And so that yeah, so that was I think one of the things that's held people back a little bit is that when they want to say, hey, what can I do with this iRanges object? I actually don't really know how I can even get the data out of it. Like, how can I get, my hands on something I can use R with on this thing? It's like this opaque object, and they have to somehow familiarize themselves with this API, rather and it's not like immediately, accessible. They can't just type a single command and then all of a sudden see this. They have to kind of dig through the help demand pages, read the vignettes, but it's not something that's like, immediately auto completing for them. But like, you could with this at syntax on these property names literally autocomplete and help the user explore that way too. So that's something that we also wanted to enable. Um, the other thing, actually, and these are the slides I added for this discussion, is that S4 dispatch is pretty complicated. And S4 supports multiple dispatch that is actually based on a distance calculation, essentially the city block distance, the Mahalanobis distance, where it's computing for each each the dimensions are the arguments in your signature, and it's computing, okay, how far off are you? How further derived are you than the class in the signature, and it adds up to the distances along the signature, and then ends up finding the closest one. And so the user is having to do this math, the developer really. I mean, the developer, but sometimes the user, but to figure out, okay, what code is actually going to be called here requires doing some math in your head, which has been challenging, at least for me, when trying to work out, these ambiguities in dispatch. So, for example, if you were to say, like, I want merge to work on a data frame in a tibble, where I can, let's say, just coerce the tibble to a data frame and then do the merge and then coerce the result back to a tibble. You can define, okay, here's a method for data frame and tibble. Here's one for tibble and data frame. But then if I forgot to define one for tibble and tibble, even though tibble derives from data frame, so it should work, but you end up calling on two tibbles, and then there's this ambiguity that's like I'm not sure which one to call here because they're both equidistant, and that can be a little bit annoying. Okay, so how does S7 solve some of these problems? So here's a summary. So we wanted them to be S3 objects. We wanted S7 to be a little bit more idiomatic, R-like, have fewer side effects, have the properties be encapsulated, so you're not necessarily exposing implementation when people are getting at the slots, and then how we might make it easier for people to think about this stuff. And there we thought about both dispatch and inheritance, and try and decide to simplify both of those. So um, yeah, so I think people may have already read a little bit about S7, kind of see the syntax, but this is how it translates from S4. So you have your where you what used to sort of define this ranges class by side effect and refer to classes by names. You're now constructing a class object. You're giving it a name, and then you're defining properties. But then the properties, the start and the width, they now have another class object. In this case, like an object that a base class object that we define within the S7 package for the numeric vector class underscore numeric. Um, and then there's similar thing for generic. So instead of a side effect, you're registering a generic by name. You're instead just creating a generic, constructing a generic with a name stored in the object end. And then you are able to then set methods given the generic object and a class object ranges. You can then define a method that computes the start and the width. Um, and here, I guess we're not using the, the same exact rules for ranges as we are with iRanges, by the way, because you would subtract one from that. But anyway, um, so anyway, this is good. Let's just keep going. So
Well, I'll just ask one quick question here.
yeah,
Um, so here we're seeing these are like first class entities in the session. So
yeah,
ranges is a new class, has to be computed in the session. There's
yeah,
no persistent definition cached anywhere.
yeah. So right,
Yeah,
well, it actually, I mean, all our code is cached like when you install a package, right?
yeah.
But yeah, you're calling you're finding these objects, and then it's actually pretty natural to, like, at the namespace level, to share these objects around. So rather than having export classes and export methods and things to import, etc., these are just objects that you can import and export using the existing namespace functionality. And so you would, if you wanted to say, define a derivative of ranges, in another package, you would just have to import the ranges object from your ranges package, and then pass that as the parent object for your class, right? So it's just very simple and just relying on the existing R functionality for dealing with objects because we're just yeah, but they do just exist at runtime. There isn't this sort of global table,
Mhm.
and to some extent that there are some downsides of that. One of the biggest ones is probably that you can't like we could probably figure out how to do this, but it's not going to be as simple to, for example, ask the question, what are all the methods that have been defined, with this class in the signature. So those types of like, if you do all the work of aggregating these things into tables, querying those tables is really easy. But we don't have those tables, so we can't. So the discoverability is a little bit impacted there. But we have to think about how to make that stuff because in principle we can go through every generic that is visible and then see in that generic, do you have a method defined for class X? So it's in principle possible to do that search, but it won't be as efficient. I don't know if it really needs to be that efficient because it's not used. We're not talking about dispatch here. We're just talking about because dispatch is easy because you're calling the generic and the generic knows what its methods are, and so for these types of global queries, that's one place where that breaks down. Um, Another obscure place where it breaks down is like you'll see later in a um, when talking about making changes or define in the multiple inheritance discussion. If you were to define in S4, you can get away with adding a virtual class to the hierarchy of an object, and you can serialize that object. I mean, you can have an older serialized object, but you load it in, and because it just knows what its class is by name, and it figures out what the hierarchy is for that class dynamically from the whatever the current table is, right? So all the metadata and everything, right? So you could do things like that. Like you wouldn't be able to change the representation because if you change the representation of the object, right, then things are incompatible. But if you just add a virtual class to the hierarchy, you can do that in a way that it's not disrupted across, like it works across serialization. But we can't, like in S7, because we're not doing these lookups, we have to have the class object as an attribute on the object itself. Like every instance of the object has a reference to its class object. They're probably only stored once in memory, but they all have this reference. And so that reference that class object gets serialized with the object itself. And so when you bring it back in, it knows what the old definition of the class is, not the new definition. So there's some things like that that we have to at one level it's kind of simple. I might say elegant, but certainly simpler. But it does bring up like new problems. Anyway, does that help?
Yeah, thanks.
Okay, cool. All right, so let's go back in here. All right, so um, yeah, so we did this stuff with properties, and the kind of cool thing was that we have these properties are objects themselves. So a property is an object with metadata, including what is the class of the property, but also it can have getters and setter functions. And so that makes you're now able to define, say, a dynamic property, a read-only dynamic property, where if I ask for the end on an object, the user does, we can now compute that dynamically. I mean, I guess you can cache it and stuff if you really want to, but more or less it's computed dynamically, and so that allows us to present essentially the slots become part of the UI because we can now, so let's say we wanted to change how one of these things was represented under the hood, but we still want to present the user like where the start property was still, a vector of integers, but we had, decided to, I don't know, represent it as a C array or something like this. We'd add like another slot, another property for this underlying external pointer to the C array, but then the start property could still behave as it did before, where it would just then materialize that C array dynamically as an R integer vector. So something like that, right? So we can inject a layer of abstraction, but with these getters and setters. It just makes everything makes it so now the sort of components of the object are now part of the UI. And so everything kind of feels like, I guess I had skipped over this concept, but there's this kind of concept in computer science where of an object-oriented user interface. It's like a formally defined thing by the small talk people. And that's what we're trying to achieve here. All right, so yeah, and the other thing, yeah,
So
but the
is getter
dispatch,
an obligatory parameter of that approach?
uh, yeah.
New
So
property?
if you
Uh-huh.
yeah, like if you wanted to create a dynamic property, right, you would need to have a getter function. But the start and with, they don't need a getter because they're just being stored
Hmm.
as numeric vectors, right? So yeah. But by the way, this is kind of a thing though too, maybe subtle. But when like in I ranges, these are defined as integer vectors, not numeric vectors. And one of the things we're currently thinking about is like if you are going to have this direct interface into the start and with, I think right now, in our start and with accessors on I ranges, we're doing a coercion to integer. So if you were to pass a numeric or a double valued vector, it would do the coercion to integer. So it would still, meet the type and the constraints on the slots of the S4 object. But here, because this is part of the UI, um, people will directly assign perhaps a numeric or double vector, into the start property. And so we're thinking about within S7 being a little bit friendly or accommodating when it comes to some of these things. So, for example, we might automatically coerce, like if you have a class underscore integer there instead of numeric for a start with, we might automatically coerce a numeric vector or double vector, into integer, for convenience purposes. So, because there's just some of those oddities of R, I mean, of computers in general, right? Where you have these different numeric types. And that can sometimes just kind of be annoying to users that they have to do those coercions. So I know we're just thinking about that, but it is like there are these subtle things that arise in this different approach that we have to think about. Um, okay, so just kind of again to get onto the more meat of this around how we're kind of changing how dispatch and inheritance works. So the dispatch shouldn't be a big deal, but we did decide to make dispatch hierarchical, so it's a lot easier to reason about. So in other words, what happens here is you start with the first argument. So you would start with in the case of like defining these merge methods with S7, you would first look at okay, is this object a tibble, or is it just a data frame? And then you would start to go down. Say if you pass a tibble, you start to go down this path. And so here X is tibble. In this case of calling merge on these two tibbles, right? So X would be a tibble, and then you would start going down this other path, and you would say, well, I don't see another one that where tibble is here, but since tibble derives from data frame, this works. So we'll just pick that. So you now no longer have to define these two tibble like the method where both parts of the signature are tibble because it just sort of naturally resolves that ambiguity by this hierarchical approach. I mean, there are definitely, I mean, there are, I guess, some downsides to this. I mean, if you really were being kind of if you really like that sort of, you know, Euclidean approach to dispatch, uh, there might be places where this is not what you want, but like in almost all cases I could think of, this is a lot easier to think about. You just look at one argument at a time. Okay, how is dispatch going to work on this argument, and then kind of go down that path that subtree. Um, oh, by the way, this is also how because people probably might want to know that rather than relying on non-standard evaluation with like call super, um, the we instead have this explicit casting of an object, like upcasting of an object. So in this case, because we want to have, if we want to call it a base merge method, but you have a tibble coming in, right? We want to be able to upcast this thing so that dispatch is no longer considers this method, so you don't end up in a in a infinite recursion here. So we so by doing this, what it doesn't actually change the class. It's kind of critical. Like, it doesn't actually change the class of X to a data frame, but it adds a essentially like a wrapper class around it, so the dispatch machinery knows to ignore everything preceding data frame and hierarchy. So you can enable to essentially call a superclass method. And the reason we decided on this was, yeah, we didn't want to have a non-standard evaluation. We had Jan Vitek involved in this very early on, and he was like, whatever you guys do, don't do any weird syntactical magic that we can't compile. So this is something that is very explicit and lets people kind of think about what's happening. And so actually, I guess what would happen here is that you have when you when you do super X class data frame, it would then no longer consider this tibble. You would no longer consider this thing as this X as a tibble anymore. So it actually call down to this one, and then this one would then force Y, to only consider data frame, and then it would finally go up, to the base implementation. But that's how this works. Um, okay. Um, so here's the thing though about the multiple inheritance. So I decided to use a real example from Bioconductor, and like this was just literally the first example that I found when I went looking, and it was sufficient for this. This is a class called rectangular data, and it's a virtual class that's extended by classes that want to represent objects with a rectangular shape. So even in the way that that sentence is written, uh, you can tell that there's one of the rules of thumb for determining whether you should be using inheritance for something is whether it adheres to the is a principle. In other words, like, is this object an instance of, this parent object or class? And um, it tends to work pretty well. But in this case, it says these objects actually aren't rectangular data. There's objects with a rectangular shape. And so that usually what that indicates, when you're making a design, is that the shape aspect um, of these data structures, right? Like that should be something that is kind of considered probably through composition or it's some attribute of the data, like whether they have a rectangular shape or some other type of shape. And so that, typically then you're going to start to favor composition over inheritance in that case. Now, I don't want to, criticize this code because this code was written with a framework that allows you to use multiple inheritance for this. And so that, the developer, Hervé obviously was simply using the tools at his disposal. So I'm not really trying to criticize the S4 implementation, but just saying that, in S7, no, you would have to do this in a different way because we're trying to simplify things and not have to consider how it's long been a common question about working with S4 is like, how do you linearize a class hierarchy with where multiple inheritance occurs? And I don't have a slide on this, but you end up in these weird diamond patterns where the as you go up in the hierarchy, you end up converging on a common class at different levels, and then so how do you decide what is the sort of the S3 class vector, the linearization of that? How does that how is that inheritance actually going to be considered? And that's something that, I don't know if anybody, I actually don't know how S4 does that off the top of my head, but it does have a rule. It didn't always have a rule. I thought it used to be a little bit, it simplified itself over time, but anyway, it is, a complication that users don't want to deal with. And also I think as I said, like there might be a more natural design. So, what a rectangular data though is aiming to do is define a bunch of these methods that these classes with a rectangular shape would need to define in order to be compatible with like the base R API and things. So I'm just trying to just to factor that to share that code. And another thing about when you talk about inheritance or misuse of inheritance, it a lot of times, what these books will talk about is like if you're doing this just to share code, you're probably misusing inheritance. Um, and you should instead favor composition. But anyway, um, so data frame is so for example, data frame, right? Data frame is a list. It's not a rectangular data. It has a rectangular shape, but it is a list. So so we want data frame to still, inherit from list, but we need to do something else for rectangular data. So as I was kind of saying, like it defines this is just a couple of examples of how it defines these dim and dim names. So that if a class defined and row or encol, then it would automatically get a dim method. We wouldn't have to worry about the dim method or the dim names method. And S7 would require a different approach here. So the simplest thing I could think of was that you would simply define a common set of functions that you then just set as methods of these different things. So if you want data frame as a Rails experiment to both not have to worry about rectangular, call it a dim implementation, you would just implement once in a function and then call it, and then use that function multiple times. Um, but that does require you to have every class will have to stay in sync. Like as new rectangular data implementations come about, you would have to, like, oh, we could share this code, we can share this code, like, we can share dim names, now all the classes have to be updated so that they're registering their method, their a dim names method using this common implementation. So it's not quite as good as multiple inheritance for that. Um, and anyway, I couldn't really think of a obvious way of doing this. So a lot of what do you call it, like message passing, the typical OOP approaches. Some of the newer languages will have things like mixins. Java actually, which is kind of famous for saying "Thou shalt only use single dispatch," is has interfaces that kind of allow for stretching that a little bit. I mean, they're not obviously it's still single inheritance, but you can have interfaces, and those interfaces nowadays can have default methods, default implementations of methods that they declare. And so that would be one way to do this. Like you would have like if we're doing this in Java, you'd have all these things implement some common interface, and that common interface would have default implementations of these things. Um, but that's effectively emulating a more general concept called mixin. So there are languages that have this concept of a mixin where you just have like a set of fields or a set of methods that you can then just kind of shove into and out. Again, this is not functional OP, but like where you have the class that has methods and fields, and you can just say, here's a bundle of methods or a bundle of fields. So you can just take. Anyway, different approaches, but you're not changing the hierarchy, but you're sharing code. But I couldn't really come up with a clean way to extend S7 and do something like that and like over the long weekend. So but I think he could think of a new design that where in this particular case, right? So just specialize to this particular rectangular data problem, where you say, okay, look, all the um, rectangular classes, there's some form of collection, and that they all consist of multiple data points or hold multiple data points, and their rectangularity is naturally represented as sort of an attribute of the object. And so that motivates the design where there is some common collection class maybe at the top of the hierarchy, where even like summarize experiment and data frame. I mean, probably right now they both inherit from like what is it a- annotated or something, right? They both derive from that. But you can instead have like, okay, well, these things are all actually collections too, and so you have like this common collection class that, let's say, list, the capital L list, derives from, and summarize experiment derives from there. And then you can, and then with that common root class of collection, which doesn't violate the ISA principle, right? Because they are all actually collections. You can then say, though, define a generic, say, ndim, number of dimensions, and then have each of those classes define a method for ndim that returns two. And then you have all these methods on collection that say, if you have two dimensions, I'll look for the n row and the n col. Like for the dim method, I'll look for the n row and n col and concatenate them and give you dim if your dim is two, n dim is two. And so something like that might have worked here. I mean, it's obviously more disruptive than the surgical change that Hervé made by just adding rectangular data in as another, class. Um, but either way, that's an approach that could be taken. So I could pause here, like if you guys want to discuss any of these things. The rest of the talk is just kind of mostly examples of how to work with S7.
Well, I think it was great. I've already done a fair amount of intervention, so let me hold back and see if other folks have some more comments. I would like to do a little more on multiple inheritance before we move on. No other comments or concerns?
No, yeah, maybe I missed it, but I was wondering how you define an inheritance of an S7 object. So if I have an object, I want to include, so I want to define a new class, right? But I want to include some other object. So it inherits from that object. How do you define that? It's like you define a new class like that,
Yeah,
or
right. So I guess I haven't shown an example of that yet. It's later. There are examples later in the talk, but you would the new class function has an argument for the parent class. And you just pass that parent class object in.
okay. So you just define the new class. You say the parent is single cell experiment, for example, just
Yeah.
and then you can build on that new attributes, right? New, how do you define it? Sorry.
Oh, the properties or
New properties for that, and
yeah.
they can be methods or just properties per se.
Yeah, right.
That's
You can define
nice.
the properties and you can define methods as you currently can. I mean, like, that the syntax. So the methods are defined on generics, not classes, right? But yeah.
Okay.
Yeah, why don't you go ahead with
Thank
the
you.
examples when you're ready? I'll hold back on multiple inheritance. We'll do it next time.
Oh, okay. Yeah, we only got 6 minutes, so last chance if anybody wants to say anything. But yeah, I will quickly run through some of these. All right. So, arguing for why we would want to have a LM interface for R, not important. Um, so we can So one of the things that I kind of point out real quick is that we have this colon equals operator that we're playing around with, which is it's something that's a valid R syntax, but it's never actually been defined. I think it was actually valid S syntax that may have never been defined, and so we're currently using that now, and this is doing like non-standard evaluation right now, to take the symbol here and pass it in as the name argument on the function being called on the right hand side. So it quotes the left hand side and passes it the name on the right hand side. So it allows you to not have to type the name twice when defining these objects. So anyway, LLM backend, right, is a new class. We support abstract classes. So and then we can have our LLM or our model object that points to this backend. Might be like an OpenAI service or something like that. But anyway, this is how you would do something like this, right? So I haven't shown inheritance yet, but I'm showing the how you would define class of properties. Um, there's one issue, of course, we all always end up with when doing programming in R. It's so hard to write software in R, right? Because you say, oh, I just want to use a character vector, but it's a vector, an array of of strings. And you might not want it to have NA values, or you might not want it to be, anything other than length one. You want a scalar, right? And so the properties support validation. So you can define a validator on the property itself, not on the class, but on the property itself, to say that, you must not be an A, you must be like one, you're a scalar. Um, but we have to do that for a lot of things. So we have to do that maybe for both the instructions, like this, the instructions, by the way, are like the system prompt of the model. But you can have you might also have the name of the model, right? Like GPT-4o. And we want to do this for name also, right? So we end up having to write the validator a bunch of times. You could do that in a function, like have a validator function you share. But another way, because these things are just objects, these properties are just objects, you can just define the property once, and then reuse the same property multiple times. There's property definitions, right? They don't actually store any data. There's property definitions, metadata. So you can just reuse that property object multiple places. So that's pretty fun. Um, Skip that. And then we could do so anyway, we can do things like class unions. So let's say we want to make these both support null, right? We'll make them nullable. We can define a property that's nullable, and the way we do that is, in S4 we would say set class union null character. Here we just have the syntactic sugar of a little bar symbol, pipe symbol, and then you can see null character, and it allows both. Good. So then we can also, here's a little helper function I defined so that you can very easily, using pipe syntax, say like with a default. So, it's just defining the default part in the property metadata, your helpful assistant. So, you can very quickly, without having to define like a whole, without having to call like new property, you can just very easily just like slap a default on a property. Here's where it shows inheritance. So we had our LLM backend. You can have a remote LLM backend that inherits some LLM backend. So this is how you just pass it's the second argument. The first argument's the name, which has been, supplied by this. And the second argument is just the parent class, and then you get LLM backend. Um, they can have an OpenAI backend, which extends remote LLM backend, and then, with its URL defaulting to the openai.com. Then here's how we define generics, as you've seen before. So we can have our chat completions generic, which is just going to use header two. This is literally all the code you needed to call the OpenAI API. A couple helper functions, and then you can also define methods on S3 generic, so the predict S3 generic. So we can define a little predict method, and if you just pass it a string, it'll run the chat completions endpoint and give you back a response to your message. Probably not going to do a live demo today, but that's kind of a quick run through of how that works. So
Is Elmer actually using this stuff?
no, Elmer's its own thing. Yeah.
Uh,
I define this is just for this talk. I
okay.
define these things. I do have a package I'm working on, which hasn't been released publicly yet, but yeah, Elmer's doing its own thing. Oh, but Elmer is using S7 though, in limited ways. Hadley's
Okay.
kind of playing around with it. Yeah. Um,
Well, we're at time. Really very a wonderful talk. Thank you.
mhm.
I know we're being recorded, so others can see it. I think it'd be great to have Hervé go over it.
Yeah.
Uh, but you know, I'm going to have to bail out. But thanks so much.
Yeah. Thanks. Thanks a lot. See you,
Do
Vince.
that much. All right, see you.
All right. So.
Okay, so maybe next time we'll have the live demo, or
Yeah, we can go into more detail next time, or people you're free to follow up offline if you have questions about things. So
yeah,
happy to.
yeah, that would be nice. Yeah. Okay, thank you very much.
All
So
right.
see you in the next third Tuesday of the month, right?
Okay.
Okay,
Well,
thank
see
you
you
very
later,
much.
guys. Bye bye.
See you. Bye bye. Bye bye.
Thank you. Bye bye.
Bye. Thank you.